Rapidly evolving languages, frameworks, and paradigms means that for a software engineer, whenever we look back on old code, we're instinctively drawn to want to rewrite it. Because in the time that's elapsed between when we wrote that old code and now, we've learned a bunch of things and there is a bunch of new things at our disposal that would inherently allow us to solve this problem in a better way. But these well-intended rewrites, they end up overburdening the team and the engineer into burnout, and they produce significant risk for the business. Hi, I'm James, and this is Paved with Good Intentions. Software engineers are an eternally curious bunch. And when you combine that with the torrent of new technologies that are available, new frameworks, languages, ways of thinking, ways of doing, ways of writing code, combined with the fact that we're always learning. Whenever we implement code, whenever we solve a problem, we're learning from that and previous things we've done as to how better to approach problems in the future. Now, when you take the combination of all these things, it's just natural that when a developer looks back on an old piece of code, they're drawn like a gravity towards wanting to rewrite that code because they can immediately think of a better way to solve that problem. They look at the old code and they straight away think, oh, I know a better way to do that now, whether it be through something they've learned or whether it be through a new framework or language that's available that would be a better way to solve that problem now and probably result in a better way to maintain this project in the future. But rewrites that take the approach of stopping development on the old system while you rewrite it into a new system pose a number of challenges. The first challenge you're going to run to is this, and there's a great maxim that sums this up. And it says that unless everyone that is present when 1.0 was written is also present when you write 2.0, then you don't actually end up with 2.0, you end up with just a different but new 1.0. And what this speaks to is the fact that there is a ton of subtle business logic that gets codified in software that no amount of documentation or test writing will ever be able to accurately capture. Even with technical writers on staff and a huge amount of tests, you're still going to have things that fall through the cracks. It's inevitable. And because it's inevitable, when you take a wholesale approach to rewriting a particular system, when you go and put that new system into production, it doesn't behave quite like the old system did. And because there are these subtle differences in behavior, that's when the project gets unstuck. That's when downstream systems are impacted, and worst of all, the customer gets impacted because their product that they're used to using now doesn't quite do what they used to do. And unfortunately, the real gotcha here is that often it's those little edge cases that you had to implement for that one customer, that one special venture, that one special thing that if we just did it would unlock millions of dollars, but it ends up being a subtle little branch of logic that gets lost when you go and rewrite the system. The other issue is this gap that forms between the old system that's in production and the new system as you're writing it. Now, unless you are in the most rarest of circumstances where you have the luxury of no longer working on the old system, you're inevitably going to be in the position where you're having to take change on the old system while you're writing the new one. Now, that can be from ongoing feature development or urgent business needs that come along, especially if you're in a small company. Right? Small businesses thrive on being able to quickly pivot to solving problems for customers. And so you very rarely get that luxury of actually stopping development on the old system while you write the new one. And that's where that gap forms and begins to widen throughout the rewrite project. And this is what drives the burnout and the overburdening of the teams. Because while you're rapidly trying to bring up that new system, you're also having to take change to the old system to support it, and you're then having to duplicate that change into the new system as well. And that's a hell of a lot of work to put on the team, and it also ends up slowing down the pace of delivery for the business. And that's the other major problem you'll run into here, is that drop in productivity is bad for you and your team as well as the business. For you and your team, it's very difficult to sustain a sustained period of lower productivity or lower output for the business just because you're rewriting code. Because you got to put yourself in the business shoes here. If what you're doing is rewriting a system, which means it'll do what it used to do but is somehow better, well, really to the business, it's a net zero change, and more often than not, a net negative change because a huge amount of investment in time has gone into rebuilding the system. But it just does what the old system does, and maybe there's a little bit more functionality you added along the way. The premise that a rewrite will be infinitely better because it's going to be more efficient, it's going to be easier to support, etc. down the line, those premises never quite eventuate. And they don't eventuate because of the combination of the lost logic along the way, which makes for a very bumpy move into production of the new system, as well as just the overburdened and burnt out team that has struggled to get to the point of getting the new system into production while maintaining their old system. But there is a way to get from an old system to a new system. And the way to do that is incremental change towards a desired end state. It's okay to think of a better way to solve the problem. It's okay to have a grand vision of how you want this system to exist. And it's especially okay if that desired end state has absolutely no remnants of the old system present. It could be in completely new language, tech stack, dependencies, everything. But how you get there is the key to success. And the way to get there is through incremental change towards that end state. And what I mean by that is you've got to find ways to decompose that old system into smaller subsystems or feature by feature, and take those one by one, build out just enough functionality to satisfy that need, and get that into production as quick as you can. Now there's two key elements there. Take small isolated chunks of functionality, build out just enough support for those, and get that into production ASAP. Building out the small amounts of functionality helps to limit the blast radius from the potential downstream impact of these changes. And it also helps you validate these changes. Because it's small, isolated pieces of componentry, and perhaps it's even interfacing with the larger system that you still own, it's much easier for you to validate that it is a like-for-like implementation of what you used to have. And if it doesn't work, if there is some subtle logic lost, then the downstream impact shouldn't be too big because it's limited to just that feature or that system. But the other thing that's really important here is that you get it into production as soon as possible. That helps you minimize that gap. Right? By getting it into production, it means that it's production verified, and if the business needs you to change something or adapt a feature, then you can do that just on the new code base that you've rolled into production. And that's an immensely powerful position to be in. Now, on the outset, some developers will push back on this. They'll say, but this means I've got to work on that old code base for longer. Every time we touch that, it falls over, right? And yes, it's true. An incremental approach here will mean that you're having to work on the old system for longer. But because it is working with these incremental pieces that helps to isolate the impact and get you into production faster, you end up reaching that end state in less time overall. And yes, it means they won't be able to immerse themselves in the new technology completely, all up at once, but the reward here is sustainable change. And there's some other benefits that the team gets along the way. If you truly take on this approach of incremental change in these isolated pockets, then as you take each of that isolated subsystem and feature, you can wrap it in the right layers of abstraction such that it continues to evolve on its own, with autonomy, but in isolation. Right? If you have the right abstraction layers to the left and right of all of these little subsystems, then down the track, even if you had to rewrite them or enact some huge technical change to that subsystem, it's a smaller piece of the puzzle which makes it infinitely easier to tackle that change rather than a large-scale change and a wholesale rewrite. But here's the really powerful thing for us as leaders of software engineering teams. If you decompose this system into these smaller subsystems and features, build the right abstraction layers, the right API boundaries, the right communication contracts between them, then you can overlay an organizational structure for your engineering organization that matches these abstracted subsystems. You can have these subsystems be owned by particular teams, and then if you staff those teams with the deeply integrated skill sets such that they have self-contained ownership and autonomy over those components within themselves, then what you end up with is a boost to productivity and a huge boost to morale that will be far greater than any rewrite could have possibly gotten you. Hi, I'm James, and this has been Paved with Good Intentions.